Multiply by 6 on top. I'm going to multiply by 6 on bottom. 12 times 6 is 72. So there's 72 hamburgers. Okay, next. This is number 10 in your book, 7 here. That's stickers. A sheet of 28 stickers has star and heart stickers on them. There are 16 heart stickers. So if I do, so there are 16 heart stickers. And 28 total. How many heart stickers does 140, a pack of 140 stickers have? Okay, so we have 140 total. We have to figure out how to get from 28 to 40, or if we can even do that with a whole number. So I'm going to try 28 times 5. 8 times 5 is 40. 2 times 5 is 10, plus 4 is 140. Oh, good. So we're going to multiply by 5. If I multiply by 5 down here, up here, when I multiply by 5, we have 16 times 5. 6 times 5 is 30. 5, 6, 7, 8. So we get 80. So we have 80 heart stickers, which 16 over 28 equals 80 over 140, because that's what we have right over there. Okay, keep going down. They have another question for us. How many star stickers? So first, they told us it was 16 heart per 28. So we need to figure out how many of those 28 are stars. To do that, we're going to do 28 minus 16, and we get 12. So we have, let me erase some of this right here for us so we have some room. So we did 28 minus 16. We get 12 star. So I have 12 star over 28 total. And I need to get 140 total. Remember, to get from 28 to 140, we're going to multiply by 5. If I multiply by 5 on bottom, I'm going to multiply by 5 on top. And 12 times 5 is 60. So this time we got 60 for our answer. And the ratios we used were 12 over 28 and 60 over 140. Okay, part C. What is another way you could have found the number of star stickers in a pack of 140? We could have just taken 140 right here and subtracted by 80, and we would have gotten 60. So we could have subtracted 80 from 140 and got 60 right there. Next. Okay, in your book, you'll be on page 172 now. And let's check out these last problems in your book. This is number 11. Kyle recorded the results of his basketball free throw practice for 3 different sessions in the table shown. Any attempt not missed is a free throw he made. So, are the ratios of misses to attempts in the table equivalent ratios? Yes, because of this right here. B. If the ratio remains the same, how many free throws would Kyle make if he misses 15 free throws in his next practice section? So let me get this erased. So his first one that he had, there's 3 misses, 10 attempts. And we want to get if he had 15 misses. So 3 to make the 15, we multiply by 5, and then 10 times 5, because we multiply by 5 up here, we have to multiply by 5 in there, is 50 attempts. Now, it asked, would he make? So if he missed, we'd be taking 50 minus 15, and that would get us 35. We had to do the subtraction because they want to know how many he made. If you would have said 50, that would be the total shots. If you would have said 15, that's what they missed. So our answer is 35. Number 9. On a small island, 63 people lived on 21 acres of land. If the ratio of people to acres is about the same on each acre, how many people would you expect to live on 1 acre of land? So I have 63 people on 21 acres. We want to figure out for 1 acre. So I'm going to be dividing by 21 to get 1. If I divide by 21 on the bottom, I'm going to divide by 21 on the top. 63 divided by 21 is 3 people. Okay, part B. If another 42 people moved to the island, so if I had 63 people and then another 42 moved there, 5, 10, so I have 105 there. If another 42 people moved to the island and the ratio of people to acres is equivalent to the original ratio, how many acres will 105 people live on? So we're going to take 105 and we're going to divide it by 3 people. So 105 divided by 3. 3 goes into 10 3 times because that is 9. 10 minus 9 is 1. Bring down our 5. 3 goes into 15 5 times. 3 times 5 is 15. With no remainder, so 35. Okay, and then number 10 in your book is number 13. So the length to width ratio of three rectangles are equivalent. That means they're equal. One rectangle has a width of 2.5 centimeters, a length of 15 centimeters. The second rectangle has a length of 9 centimeters. What is the width? So what I'm going to do, I'm going to take my 15 down to a 3 because I know I can change 3 to 9 because 15 divided by 5 is 3 and 3 times 3 is 9. Now up here, I'm going to have to do 2.5 divided by 5, which is 0.5. And then I'm going to multiply that by 3, which is 1.5. This one is a little bit more complicated, and that's cool if you're not understanding it as much because we have a lot more decimals going in there. Part B, the third rectangle has a width of 6 centimeters. So I'm going to take, so we have the width of 6 centimeters. So I'm going to take our 2.5 over 15, and the width was 6. Get 2.5 to 6, or this way, I'd have to multiply by 2.4. I guess it's going this way. So 15 times 2.4 is going to be 36. So to do that, I took 15 times 2.4, get 20, 4, 5, 6, 0, 10, 2, 3. We get 3, 6, 0, but there's one spot. So 36. Okay, and part C. Determine the length of width of two more rectangles whose length to width ratios are equivalent to that of the three rectangles. Explain how you found the length and the width of your rectangles. So they have lots of words here. And it's going to be this one. Rectangle 1 has a width of 5 centimeters and a length of 30 centimeters. Rectangular 2 has a width of 7.5 centimeters and a length of 45 centimeters. I multiplied the width of the length of the first rectangle by 2 and then by 3. Multiplying both parts of the ratio by the same factor creates an equivalent ratio.